chapters 1, 2, 3, Introduction to Statistics, Exploring Data with Tables and Graphs, Describing, Exploring, and Comparing Data. Let's look at a couple of questions. The value of variance and standard deviation is never negative. All you have to do, look at the formula. When we pick up the formula for each one, let's just quickly discuss that. Here's the population variance, the summation of x minus mu, quantity squared over n. You take a root, becomes the standard deviation for the population. And if you're dividing by n minus 1, it becomes the sample variance and then sample standard deviation when you take a root. By the way, you want to be very careful whether it's dealing with the sample or population because the formulas are slightly different. How do we know these values are in fact non-negative? Because if you look at the numerator, is being squared up and add up. So the sum of a bunch of positive numbers, the worst scenario is 0, okay, because x minus mu can be 0. And the denominator is a discrete positive value. So it's the ratio of two numbers, none of which is negative. Therefore, the answer is positive. As far as the kind of quantitative versus qualitative data in general, and we do have different classifications. In general, when you deal with numbers, it is quantitative. When you don't have a number involved, it's qualitative. However, there are numbers that are qualitative or nominal, if you will. Something like your student ID, zip codes, things of that nature. So weights is quantitative and gender is qualitative. Population in general refers to all. It's loosely put, okay, one easy way to describe it, anytime that we refer to the entire subjects under study, all. So population is the complete collection of all elements that are being studied. The value of a middle term, if it's a rank data, and that's the key, it's called the median. The one which happens the most, in other words, the one with the highest frequency of occurrence, we call it a mode. The number of chairs is discrete. You can have 2, 5, 10 chairs, but you can't have 7.1. So that's a discrete value, not continuous. Number 7, discrete is the answer. So the proper answer would be discrete. So continuous is wrong. On a Pareto chart, just like histogram, for example, in essence, the frequencies, they go on the vertical axis. All right, so we are given the following table. And we want to find a bunch of stuff here. Let me just put the numbers. This is 1, 2, 3, 4. Yeah, 5 classes. The next one is the class width. So part A, the number of classes is obviously 5. I just counted it for you. To calculate the class width, you have a choice. Pick any of these two. You can pick this two. You can pick this two. Subtract the top from the bottom. As long as they are in consecutive classes, you can do that. However, if you pick a class, if I pick any of those classes, doesn't matter which one, let's say this one, then we have to use the upper limit minus the lower limit plus 1, which means 20 minus 11 plus 1, giving you the same answer, which is 10. By the way, lower limits, upper limits, frequency. So what is the midpoint? In general, the midpoint, add them up, divide by 2. The lower limit plus the upper limit divided by 2. So we want it for the fourth class. This is the fourth one. 41 and 50, add them up, divide by 2, and you get 45.5. The lower boundary of the fifth class, the upper limit of the first class, the sample size, and so on and so forth. As far as the boundaries are concerned, and I will show you with the table on the next page, if you add up these two and divide by 2, in other words, if you find the midpoint for that, it's 20.5. It will be the lower boundary of the second class as well as the upper boundary of the first class. That's how you calculate that. Therefore, if we want it for the fifth class, we have to do these two. 50 plus 51 divided by 2. The upper limit of the first class. As I said, these are the lower limits, those are the upper limits. Okay, so the upper limit of the first class is 20, the upper limit of the last class is 60, so on and so forth. The sample size, how do we come up with the sample size? Here's the frequency, add them up. Add them up. That's the sample size, okay? All right, so you add them up, 5 plus 6 plus 9 plus 11 plus 4, n or summation of x. That is the formula, or you can say sample size is that in that format. Either way, you come up with number 35. The next one is asking for the relative frequency. Relative frequency is defined as frequency divided by size. So for this one, for example, would be 5 divided by 35. For this one, 6 divided by 35, so on and so forth. So for the first class, 5 divided by 35 is equal to precisely 1/7, and it's an approximation. If you are carrying decimals, you want to make sure that you follow the instruction, you put the proper number of decimals. Let's make some more sense out of this by looking at the next page and having this table, given this table, we want to look at this table. So take a look at what happens. We have the given table. So remember, we calculated the width and we ended up with 10. So you add up these two numbers, you divide by 2. Now, do you have to do the rest? You can do the same thing. However, it's easier just to add the width and go down. So just keep on adding the width, which is equal to 10. Now, when you find this boundary, now again, just add 10. Keep on adding 10. In other words, just one calculation is enough. The rest of it, since you know the width, add up the width. And how do you get to this one? This would be 20.5 minus the width. And as I mentioned, the relative frequency is just f over n by definition. And what I want to add here is that relative frequency, sometimes they ask for percent frequency. You just change it to a decimal and then percent accordingly. You want to make sure you carry enough decimals so it makes sense. We are looking at a similar question, and it has tons of parts. We are going to look at each part given this. So the following frequency table describes the speed of drivers ticketed through a 30-mile-hour speed zone. So it was a 30-mile-per-hour speed zone, and these people got ticketed. Between 42 and 45 miles per hour, there were 25 drivers, 46 and 49, 14, so on and so forth. By the way, again, before even we move on to the next page, I want to make sure that everybody understands. If I'm looking at this one, again, number one, I have 1, 2, 3, 4, 5 classes. So that's number one. Number two, just pick up any two consecutives, and 57 minus 53 or 58 minus 54. The width is simply 4. Two pieces of information that are important before we move on. Number one, how many classes we have? 5 of them. Number two, what is the width? Number three, as we look at this, these are the lower limits, these are the upper limits, and of course, these are the frequencies. So we want to make sure that it makes sense to us. So let's see what happens here. We are looking at now calculation of a relative frequencies for all classes, which we mentioned. For each class, you divide by a total size. So the very first thing I need to do is to add them up. So 25, 14, 7, 3, 1. So let's add them up. And so that's the sample size, n equals summation of x equals 50. That's the total. And if I want the relative frequency, I'm going to divide 25 by 50. 14 by 50, 7 by 50, 3, and 1 by 50 for each one. So that would be the relative frequency. So what percentage represents the speed of 53 miles per hour or less? Let's take a look at number 53. Here's number 53. So what is that? 7, 14, 25. Add them up. And because we want the percentage, we divide by 50 and change it to a percentage. So we add them up and divide, and there you have it. The next one is asking for what? The boundaries. And I mentioned, we add up these two, divide by 2, we get 45.5 as the upper boundary of the first class, lower boundary of the second class, and we can use the width of a 4 to add and subtract to get the rest of them. So take a look at the following table. Let's quickly recap what we did. So this is given, this is given, this is given. As far as the relative frequency, 25 divided by 50, which is 1/2. 14 divided by 50, which is 7/25, and the rest of them. 5 and 46, when we add them, divide by 2, because we're interested in them, we get 45.5. So let's see, these two are the same. Then what do? We said the width is equal to 4. So if I add 4, I get 49.5. If I add 4, I get 53.5. I don't have to recalculate it using the midpoint. That's easier this way. And of course, to get to the first one, to get to this number, I subtract 4 from 45.5. In other words, let's just write it here. 45.5 minus 4, that gives us this number. There's not a lot of calculation involved because you know the width. You want to construct a histogram. When you want to construct the histogram, as far as the horizontal axis is concerned, can be the limits, midpoints, or the boundaries. Because we use the boundaries more often, especially for something like an ogive, we're going to stick with that. What about the vertical asymptote? It depends. You want to read the question. Vertical asymptote is either the frequency or percent frequency. Sometimes they just say relative frequency. Ultimately, they look the same, but you want to stick with that. Since they say frequency, you want to stick with the frequency. So you basically draw a grid, and then you have some vertical strips adjacent to each other. You give it some identical width for a lower boundary to upper boundary of the first class, and the height, since we are dealing with the frequency, is 25 for the first group, 14 for the second vertical strip, so on and so forth. So take a look at what happens here. We have 25, and then we have 14, and so on and so forth. 7, 3, and 1. So that is the height. By the way, as far as the vertical asymptote, many times what they do is instead of starting at this point, they move it to this side and start from here, because it doesn't mean this is 0, 0. Remember, when we look at basic algebra, the rectangular coordinate system, this is 0, 0. So if you did that, and again, it really depends on the text, it doesn't. So this is your horizontal axis, and this is the vertical axis. Now we are asked to come up with the cumulative frequency distribution table. Again, here's what's given to us. When we say cumulative, so you are going to accumulate, you're going to add. So in order to add, it starts from the beginning always. So it's always 42. So if I want to go for the cumulative frequency distribution, what happens to the first group? The lower limit will always be the lower limit of the first class for each and every one of them. So if I change everything to 42, the frequency remains the same for the first one, but for this one is 25 plus 40. For this one, add them up to 7, for 25, 14, and 7, all of them, and all the way to the end. So take a look at what happens. So I want you to pay attention to the second column. We discussed the third one. All of the lower limits are 42. So the first one, frequency doesn't change, but the next one, just add them up. And when we do that, this number is always n. The relative frequency is the same thing. You divide by the size. So as a result, there are a few things you want to pay attention to. This is always equal to n. This is always equal to 1 or 100%. Always. I can't emphasize this enough. The other thing I want to mention, sometimes instead of this, they use the boundaries. So they say, if you recall, as far as the boundaries are concerned, they say less than 45.5. And by the way, let me just make sure everybody understands how this thing works, because in case you are making up a frequency distribution table. When you use the limits, 42 and 45, they both belong to the first class. I'm going back to actually this one, I should say, right? 42 and 45, whereas 46 belongs to the next one. So how does it work when you go with the boundary? It means everything up to and not including 45.5 belongs to first class, so less than 40. So if you have a number 45.5, precisely belongs to the second class, according to this concept. Sometimes they even use the lower limit of the next class and they say less than 46. The best course of action, in my opinion, is this, but stick with what they offer you. The next thing is to draw an ogive. So let's see what's an ogive. We use the vertical and horizontal asymptotes. The horizontal asymptotes, as mentioned, we are going to use the boundaries. So here's the boundaries we are going to use. So 41.5 and then 5 all the way to the last. The lower boundary of the first class always corresponds to 0. The upper boundary of the last class always corresponds to either n, which is 50, or 1 or 100%. Which one? Well, you look at the question. The question is asking cumulative what? If it's asking for a cumulative frequency, then you are going to use those. But if it's asking for the percentage, now instead of 25, you really have to use 25 over 50, 46 over 50, 49 over 50, 50 over 50. The last one is 1 or 100%. Because it's asking for the percentage of it. Okay, now what do we do? Let's just quickly go over the concept here. As you can see, we have the boundaries here, and we go all the way up to, let's say, 100. This means percent, okay? The lower boundary of the first class corresponds to 0. The upper boundary of the last class corresponds to n or 100%. And everything else, it corresponds to the proper percentage. We have to have the percentage that we have calculated. For example, as I said, this is 100%. And now this is the upper boundary of the first class and corresponds to 25 over 50, which is 50%. And they're all line segments. You connect them with the line segment. The next one is 39 over 50, which means 78%, and so on and so forth. The next thing is asking, using the ogive, find the percentage of drivers who drove 47 miles per hour or less. So you're going to locate 47 along the horizontal axis. Corresponding to that along the vertical axis is the answer. Here's what we do. Take a look at this location roughly. So locate 47 along the horizontal axis. Okay, number 47 is somewhere between 45.5 and 49.5 on the horizontal axis, which corresponds to approximately 60%, maybe 61% of drivers drove 47 miles per hour or less. The following data is given. I'm going to find a bunch of stuff. In order to find all of this, we need to rank it. We don't have to rank it for the mean. But since we have to rank it for the rest, don't take a chance. Rank it immediately just to be on the safe side. So the very first thing is we are going to rank it. And I've explained here that we don't need to rank to find the mean. But if I need to rank even for one of those calculations, I'm going to rank it because I don't want to make a mistake with the rest of it. First, recognize that we are looking at a few employees, and that means a sample. So X bar is summation of X over N. So add up, divide by size, there are 18, and that is the mean. As far as the number of decimals, there are a couple of ways of approaching, and one of them, they normally expect you to carry one more decimal than the given data. In some cases, they want you to carry the same. And in most cases, they tell you how many decimals. Stick with that. I personally like to carry a lot of decimals to be on the safe side, because otherwise we end up with the round of error when we want to calculate other things. So the next one is the mode. There is no mode. Why not? Take a look. Nothing repeats. Since nothing repeats, there is no mode. And that's really the idea behind a mode. Median, you are going to look at the middle of the data. Now, to find the middle of the data but n is 18. So if you put 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's in between here. That's the median. And if it happened to be an odd number, there is one number in between, and that's the answer. But when it's even, there is no number in between. So you find the midpoint of the two. So 25 and 27 divided by 2 is the answer. The next one is asking for the mid-range. Mid-range by definition is max plus mean divided by 2, or high plus low divided by 2. Again, I hope you realize right away, if I don't have them ranked, I may make a mistake. Range, the same thing, max minus mean. The ranking is extremely important. So the largest number is 42, the smallest is 14, and there you have it. Okay, so ranking is extremely important. You may have noticed that these two numbers are the same. That is really not the case. This just happened. That is not the case in general. It just happened. So be it. So again, mid-range has a specific formula, max plus mean divided by 2. Whereas range is max minus mean. They are not the same. They are not the same. In this example, it just worked out. All right, we want to find the variance and standard deviation. So as far as first, notice a few employees that gives rise to the equation of a sample. I want to make sure you know that. And here's the methodology to find the answer, or here's the methodology. Either way, it doesn't matter. I want to quickly go over both ways. By hand, normally you don't do this by hand, you do it with technology. But if you have only a few pieces of data, it is manageable, and you really need to know how it's done. So for the sake of argument, let's look at the first one. Of course, we counted 18 was n, so the denominator for if you use this one is 18 times 18 minus 1. I want to go over that first, and n is 18. Now, what is summation of x squared? That means square each piece of data. So if the first one, remember when we ranked it, it was 14. So if the first one is 14, you square it, plus, and the second one and the third one, the last one is 42, you square it, you add them up, you multiply by 18. But this one, summation of x, and we had this because we had to come up with x bar, which is summation of x over n. So we add them up and then square it. Now you go through the process, you come up with the answer. Or you may go with this methodology. Let's see what that means. So that means the first number is 14, so 14 minus the mean squared. Take a look. The meaning of the second method, 14 minus the mean squared, plus the next one and the next one and the last one, 42 minus the mean. Remember, the mean was calculated from the previous page, squared, divided by 80 minus 1. I'm not going to, of course, finish that. We have, if we work it out, we end up with the same answer. And of course, what is the standard deviation? You don't have to do anything. Just take a root of this number. Take a root of that number, and that is the standard deviation. Again, as far as the number of decimals class, be very careful. Follow what they ask you to. The next part is asking for interquartile range. So interquartile range, by definition, is Q sub 3 minus Q sub 1. So let's discuss that. Over here, we have the median, which is also Q sub 2. Then for finding Q sub 1, by the way, Q sub 1 separates the bottom 25% from the top 75%. Q sub 3 separates the bottom 75% from the top 25%. To find Q sub 1 and Q sub 3, there are different methodologies. One easy way is to look at the bottom half, look at the top half. The median of the bottom half is Q1. The median of the top half is Q sub. This is the fastest and easiest. Now, if it happened to be an odd number, if it's odd number, then the number, as I mentioned, we're going to cut this into 2, and the median of each is Q1 and Q3. Now, by the way, it's important to realize there are different methodologies, as I mentioned. Discuss some of them as we go through it. But this is the fastest and easiest way, and you want to probably stick with that, everybody, okay? You want to stick with that. So Q sub 2 is the median. Q sub 1 is the median of the bottom half of the, or the first half, and Q sub 3 is the median of the second half, and IQR, by definition, is Q sub 3 minus Q sub 1. IQ scores have a mean of 100 and a standard deviation of 50. Whenever you do problems in statistics, in essence, you're dealing with word problems. So it's extremely important that you write the given, and it is important to understand symbolically what's given. You're dealing with a population here because it's not mentioning a specific sample. So the mean is 100, that means mu is 100. Standard deviation, that means sigma is 15. So that's the first thing, what is given? And that's important for everybody. The next part, coefficient of variance by definition is sigma over mu. the ratio of standard deviation to the mean. Now, this just makes it a percentage. So when you divide, the answer is 0.15. 15% is changing it to a percentage. If you don't write the percent, it's wrong. So that's the coefficient of variance. As far as the range rule of thumb is concerned, let me explain the meaning of the range rule of thumb. Basically, the range rule of thumb is an estimate. And if we start from the mean mu or x bar and we go 2 standard deviations on each side, that is considered the range rule of thumb, because later on, based on the empirical rule, that gives us 95% of the data. And that's good enough. And with that estimate, we can also estimate the standard deviation. If we're going to go 2 standard deviations on each side, if you happen to have the range, then divided by 4, because on each side we're going to go 2 standard deviations. This is roughly the value of standard deviation. Of course, the assumption is 95% of data is good enough. So with that being the case, mu plus minus 2 sigma, we just plug in. This is 30, subtract from 100, you get 70, add to it, you get 130. So those are the values that are considered range rule of thumb. The Chebychev's theorem is a little bit more conservative compared to empirical rule. When we don't know, we have a bell-shaped normal distribution, a curve that is symmetric. Then we go with Chebychev's theorem. And Chebychev's theorem, the proportion of values from any data set that fall between k standard deviations of the mean will be at least 1 minus 1 over k squared, where k is the number greater than 1 and is the number of standard deviations away. Now, you have to figure out what's going on when it comes to 70 to 130. We have already come up with those numbers, and they showed that that corresponds to 2. So we already have the value of k to be 2. But what if we didn't have it and we had to calculate? A couple of different ways I'm going to quickly show you how to calculate that. One is that you put number 70 here, and you put 130 here, and you say mu is 100. Now this distance is what? So is this distance. If you divide 30 by 15, gives you 2 standard deviations. Also, you can subtract 70 from 130 and then divide by 4. Remember this 4 here, and that gives you the standard deviation if you want. Either way, you got to be able to come up with k. And so with that being the case, 1 over 2 squared is 1/4. 1 minus that is 3/4 or 75%.
Professor?
Yes.
Where did you get the 4? How did you like to divide by 4?
Now you divide by k squared. K is the number of standard deviations away from the mean. So according to Chebychev's theorem, we want to see what percentage is covered between 70 and 130, right? So we have to know the distance, okay? From 70 to 130, it covers 4 standard deviations away. We need to know the distance from the mean to 70. In part B, if you go back to part B, the reason we really don't have to calculate this, in part B, mu plus minus 2 sigma was calculated and it gave us 70 to 130. And that indicates that the number of standard deviations away is 2. So we already know k is equal to 2. If we don't know, we have to calculate it. How do we calculate the value of k? You can put 70 on one side, 130 on the other, and the mu or 100 in the middle. Their distance or difference is 30. 30
Got it. Okay.
Means 2 standard deviations away. So because the number really doesn't mean anything. What matters is that 30 corresponds to how many what? Standard deviations.
Standard deviation.
Exactly. So 30 is equal to 2 standard deviations. Okay. And therefore, your denominator is 1 over 2 squared. This is 1/4. 1 minus 1/4 is 3/4. 3/4 is identical to 75%.
Thank you.
My pleasure. And The next thing is about empirical rule. Empirical rule deals with a normal distribution, bell shape. So if you start from the mean and you go one standard deviation on each side, it covers about 68% of the data. More precisely, 68.26, but roughly about 68%. If you go two standard deviations away, it covers about 95% of the data. And if we go from the mean, if we go three standard deviations away on each side, it covers almost everything, 99.7%. To answer this question, using the empirical rule, find the percentage of those who will have an IQ score of 70 to 130, we have already established it corresponds to how many standard deviations? 2 standard deviations away. Therefore, it corresponds to 2 standard deviations away, which means 95%. So 95% will have an IQ score of 70 to 130 according to. There are some definitions now, so we're going to go through them fairly fast. Parameter versus statistics. In short, parameter is a measurement, a numerical measurement that describes characteristic of a population. It goes back to a population. Whereas statistic, it goes back to a sample. Same thing that pertains to a sample. That's why when we write it symbolically, X bar represents the sample mean, whereas mu represents the population mean. We use Greek letters to represent population parameter. Random sample and simple random sample. Random sample, basically every subject has an equal chance of being picked. Simple random sample, every sample of the same size has an equal chance of being picked. So a quick explanation of that is as follows. If we want to pick, let's say, a student randomly from the class to represent the class, let's say we have 25 females and let's say 40 is the total size. That means 15 males. I'm just making it up. So probability of picking a female is 25 out of 40, and for a male is 15 out of 40 for each person if we do it randomly, and that means being fair. But if we want a sample size of something, 3, 4, 5, then every sample of the same size must have an equal chance. And by the way, how many samples there are, it's really a combination, and it is a large number. I want you to know that. We will discuss that when we go through probability. But that is the difference between the two. Systematic, convenience, stratified, and cluster. In short, systematic, select some starting point and then pick the kth element. Convenient sampling, use results that are easy to get. For example, I want to know what happens with the midterm election. I can conveniently ask my own students. So that's a convenient sampling. Stratified sampling, you divide the population into a homogeneous group and then subgroups called strata, and then obtaining a simple random sample from each group. Whereas in the case of a cluster, they are non-homogeneous, they are similar. And then when we select them, we select all of them. This is sometimes a little bit confusing. Here's the idea behind this. Let's say we have a group of students that are A group, and then B students and C students. I'm making something up. In this format, we are looking at stratified because they are homogeneous. See, they are all A's, they're all B's, they're all C's. So in this format, then you pick randomly a few from A group, a few from the B group, a few from the C group. That's stratified. However, if we do the following, let's say now we have 3 groups, and in each group we have randomly selected a few students that are ABC. So each group is similar to the next group, and any of them you pick, as long as everything is done randomly, is good. And so you can basically randomly pick one of them and keep all of them.
Professor?
Yes.
So for stratified sampling and cluster, you divide for both? You divide both groups? I mean, both populations?
Yeah, you divide the population into different groups, but the way you divide stratified, they are homogeneous within the group. So this group, they're all the same. That means anyone you pick from this group is an A student. From this group is B student, and from this group is C student. You pick a few from each one, okay? Whereas in the second case, randomly you've selected such that each group has ABC students. Do you follow what I'm saying? And therefore, when you pick one, you keep it, okay?
Okay.
All right.
Thank you.
So those are the definitions. My pleasure. Various levels of measurement, and we've been through that. In short, nominal, something that is categorical. There's really not much to it. And by the way, I think I've mentioned that, so I'm going to repeat that. There are numbers that are considered nominal or categorical or qualitative, such as your zip code, your student ID, so on and so forth. Ordinal, there is some sort of an order, a large, medium, small. That's the idea. Interval and ratio. Interval is basically something that there is no natural zero. That really means if you were to do some sort of algebraic operations, you could add and subtract and it makes sense. You know, that's one easy way to look at it. But so the differences, they do have a meaning. But in the case of a ratio, not only the differences, also the ratios make a sense. That means you can even figure something is twice something else. If a book is $100 versus a book which is $50, the book that is $100, it costs twice as much. That's the idea behind it. For observational and experiment, observational study, you just observe. You don't do anything. You just observe. You don't attempt to modify anything. You're not changing anything. You observe, and then you basically report your observation accordingly. And this is an example of Charles Darwin observed the finches. Whereas in the case of an experiment, you do something. And a common idea is to checking an effect of medication. So you have a group that is taking the medication and a group that is not. And they normally call it the placebo group. And so you want to see whether a medication is effective or not. So it is an experiment. It may even be that you're comparing low dosage versus high dosage versus no dosage. It could be, you know, more than just necessarily two groups. But the idea is that you are making some changes. And that is the idea behind the experiment. Given the following set of data, we want to rank him and get a box and whisker plot. So first and foremost, when we, even if they didn't ask for part A, when we want to do this, it's really a must that we have to rank it. So that's really something we have to do. So part A many times may not even be asked. You have to rank. To come up with the boxer and whisker plot, there are 5 things you need. You need the mean, okay, so we have it. You need the max, okay, we have it. I hope you see why we rank this. Then we need to find Q sub 1, Q sub 2, and Q sub 3, okay? And we already discussed the way we did it before. However, one other way is the way I'm going to discuss here. So what we did, we cut this in half. This is the location of a median. Then we have the bottom half, the median of the bottom half is Q1, the median of the top half is Q1. And this is the fastest and easiest method. Stick with that. The next one is to do the following using the locator. So K over 100, remember, this is really a percentage. For example, if we want Q sub 1, if you want Q sub 1, I want you to pay attention to this. Q sub 1, you need 25 over 100. So Q sub 1, okay, I've given you the answer. I want you to ignore that. Pay attention to this. For Q sub 1, we need the 25th percentile. Remember, Q sub 1 separates the bottom 25% from the top 75%. That's why this number is 25. So in fact, just 0.25 class, 0.25. How many do we have? We have 14. So we're going to multiply by 14, we get 3.5. This is the location we need. In other words, we need the 3.5th number. However, what statisticians do is they round up. So they go to the 4th number, 1, 2, 3. 4th number is 7. By the way, if we did in this example, if we did the method that I mentioned, look at the bottom half and the median, that gives you the same answer. The median is very simple, just the method that we've discussed. It repeats everywhere and it never ever changes for anyone. So 15 plus 15 divided by 2, the median is very obvious. So the median gives us this. As far as Q sub 3, so when we look at this one, Q sub 3 separates the bottom 75% from the top 25%. That's why we have 75 here. Take a look here. This is, let me actually change the numbers to form. This is really the same as 0.75. This is actually the same as 0.25. That's what we mean. So if we multiply that by n happen to be 14, it gives us 10.5. And then it's rounded up, 11th number. So 9, 10, 11, and it becomes 19. How do we draw that? I want to make sure everybody understands the drawing. So let me quickly go over that for you. So you have like a number line, and at top of it, at top of this number line, you locate the mean, the max, Q sub 1, Q sub 2, and Q sub 3. If you want, you know, and I'm going to erase it. So that's the idea. What I'm going to do, of course, by no means is going to be to scale. But so basically, you draw a number line, okay, and corresponding to number line, you put, and I'm not going to even put the, you put the minimum here, you put the maximum here, you put the Q1 here, you put the Q2 here. This is Q sub 3. Then I make up a box here, and then I make up the whiskers here. This is how you put them together by hand. Of course, you want to make sure it's to scale. So I'm going to erase that and again give you what we had. Why is it called the box and whisker plot? This is the box and this is the whisker. The next one is asking, do we have an outlier? Now, outlier, as far as basic definition, something which is out there, which is out of norm. And one can guesstimate whatever they want, but mathematically speaking, we want to come up with a solid method so everybody comes up with the same answer. So what statisticians have come up with the following. Q sub 1 minus 1.5 IQR and Q sub 3 plus 1.5 IQR. Those are called the fences. The numbers outside those range are considered outliers. So let's calculate all of those. So Q sub 1 minus 1.5 times IQR and Q sub 3 plus 1.5 IQR. So that is what they have come up with. And IQR is simply Q sub 3 minus Q sub 1. We have those values from the previous page. So it's 12. We are going to multiply this number by 1.5, okay, and it's 18. Now we are going to subtract this number from Q1, and we're going to add this number to Q sub 3. Those are the numbers that give us the proper range. Anything outside is out. So when we subtract 18 from Q sub 1 gives us negative 11. When we add it to Q sub 3 gives us 37. Now we are going to look at the numbers, and please make sure when you look at the numbers, numbers are ranked so we don't make a mistake. So negative 11, we don't have to worry about on the left side. At 37, what is large? Anything larger than 37 is out. Therefore, clearly, number 50 is an outlier. However, I want to also give you the idea behind what is known as extreme outlier. Instead of 1.5 times IQR, they multiplied by 3.
Professor?
Okay. Yes.
I have a question. So
Yeah.
the outlier in this one would be 50 because it's over the 37?
Number 37. Yeah, I'm going to answer that in a moment, but I wanted to hear.
Okay.
Absolutely. Yes,
Okay,
absolutely.
thank you.
So, my pleasure. So this is an outlier, and now extreme outlier, we're going to subtract 3 times IQR from 7. Okay, so 12 times 3 is 36. So 7 minus 36, and then 19 plus 36. So, but this is again extreme outlier. What number is larger? What number is larger than 37? is 50. Therefore, number 50 is an outlier. But as I mentioned, this extreme outlier is just there for your information. We are interested in basic outlier, and we got that. So 50 is an outlier. Given the data that we have, are the data symmetric or skewed, and so on and so forth? It is skewed to the right. I want you first to look at my explanation about a couple of things. It is skewed to the right, and I will show you with a little bit more details in a moment. Number one, make sure the drawing is to scale, because otherwise all bets are off. We don't know if we have it done right or wrong. Make sure this is to scale. Number two, skewed data show an uneven box plot, in which case the median cuts the box into two uneven pieces. Longer part on the right or above the median gives us skewed to the right. Longer part on the left, skewed to the left. Sometimes the box may look even or even uneven and even skewed to one side. However, the whiskers or tails on each side of the box may indicate otherwise. Therefore, pay attention to both. So take a look at the whole thing. One easy way to look at it is this in the middle. If you look at this distance, this is the fastest and easiest way to answer this. And that's not, therefore it is skewed to the right. If you were to graph it like this, it is skewed to the right.
Professor?
Yes.
So the way we identify what way it's skewed to is determining like the outlier?
Outliers do have an effect. If you have an outlier on the right side, of course, it's most likely skewed to the right. If it's on the left side, skewed to the left. But you can do the drawing. Take a look at the drawing. Look at the distance from the median to the left and right, because this part is, look at this distance,
right.
but this is more to the right. Do you see that? And because of that, it's skewed to the right.
Got it. Okay. Thank you.
My pleasure. Now we're going to do the same thing again. Only reason I'm doing this, because again, I want to show you a different way. Median is very straightforward. And by the way, this is in order. In other words, it is ranked. Again, even if it's odd class, I want to make sure you understand. If it's odd, there's one number in between, and that is your median. Now, the bottom half and the top half, there are various ways of calculating. I like to keep the one in the middle as part of the bottom half and the top half. In some instances, they drop them. In some instances, they keep it. But what happens in the long run, if you have a large data, all calculations become almost identical. There are different ways to calculate Q sub 1 and Q sub 3. Here's an easier way, as I've mentioned. So the bottom half and the top half, which was already explained to everybody. Okay, so if you look at this one is Q sub 1 and this one is Q sub 3. Now we have 5 numbers. We need 5 numbers. We do have it. What are the 5 numbers? Min, max, Q sub 1, Q sub 2, Q sub 3. And it looks like this. It has to be to scale. Now, what I want you to notice, if I were to graph this, looks like this. It doesn't have to be perfect, but it's almost symmetric. Look at this distance, everybody. The distance from here to the median, the distance from the median to the max, they're almost the same. They don't have to be identical. Okay, that would be a perfect symmetry that is actually hard to achieve. But this side and the other side to be almost the same as this distance, almost. So again, IQ are also giving you a calculation for the outliers. Q sub 3 minus Q sub 1 is calculated. And let's quickly look at it. Q sub 3 minus Q sub 1 is calculated. You multiply it by 1.5, and then you subtract this from the Q sub 1 and you add it to Q sub 3. And those are the outliers. Now, anything less than 63, we don't have, see, here's the thing that is, we don't have any outlier on the left side because nothing is less than 63. Look at 107. We don't have any outlier on the right side because 107. One easy way to see if there is no outlier, most likely it's symmetric. If there is an outlier, depends, the outlier is on the right, so skewed to the right. The outlier on the left, skewed to the left, normally, okay? Of course, depends how big the outlier is, and there are really more factors, but look at the graph. And again, extreme outliers, you multiply it by 3. Okay, this data is almost symmetric, normal, bell-shaped. Let's look at the next question. So the mean of a data is given, the z-score. We want to find the standard deviation. So if z is x minus mu over sigma, you can interchange these two. And so the mean is this number you plug in. The z-score is this number you plug in, and this is your x you plug in. In other words, if you want, you can write at top of it. So this is the mean. This is just the z-score. And you calculate it, and the calculation results in part D being the answer. So calculation 8 is the answer. We want to find the z-score to make a decision which one is a better score or worse score. Let's take a look at it. Okay, we just follow the formula, and the formula z equals x minus mu over sigma or x minus x bar over s. For the art measure, x is given, x bar is given, s is given, calculate, do the math. We end up with negative 0.8. We're going to do exactly the same thing for the theater measure. We're going to do the same calculation for the theater measure. And x is given, x bar, s, do the math, and here's what you get. Now, before we go over the answer, I want to explain a couple of things. When the z-score is 0, if you happen to have a class that they curve, the z-score of 0 means your score is identical to the class average. The z-score which is positive, that means your score is above the average. For example, if it's positive 1, 1 standard deviation above the mean. If your z-score is negative, that means it's below the average. So both are negative and both are below average. However, this is more negative. This is worse than this. So this is a better score. So both of them are negative. Both of them are below the average, but at least this is a tad better. None of them is that good. But anyways, the next one, we have a 5-number summary. Can we find the mean? And the answer is no, absolutely not. In order for you to find the mean, if you want the exact mean, you have to have every piece of data. So that's why you can't calculate the mean. You don't have every piece of data. It cannot be calculated. So you need every piece of data and the sample size you divide by it. Or you have at least the total and then you divide by the size. Which of the following is true? Before we can answer it, we really have to look at the concept of the decile that cuts the data into 10 equal parts. P, the percentile, cuts it into 100 equal parts. Q, quartile, cuts it into 4 equal parts. Since we know that after the definition, okay, then clearly this means D5, D sub 5, P sub 50, and Q sub 2, they are identical. Again, it comes from the definition. All right, let's go to the next page. We are interested in weighted average, weighted mean. So we have a student with different courses, and the courses are given different credits, stats 4 units or 4 credits, physics 5, sociology is 3, literature is 2, and tennis is 1. The way the GPA is calculated is using the weighted average or weighted mean. If you receive an A, you got 4.0, B 3.0, and so on and so forth. So C is worth 2 points, and D is 1, and F is worth nothing. So the reason we use this, here's the formula that we use for the weighted average. Understand the concept. It's extremely important to see why we calculate the GPA in this manner. Think about having only 2 courses. We want to make this simple. One is A, one is B. So if we have 1A and 1B, does it mean our average is 3.5, right? Smacked in between, because A is 4.0, B is 3.0. It depends. If A is a 5-unit course and B is a 2-unit course, then it's heavier with the A, towards the A, so it will be larger than 3.5. On the other hand, if the B course is worth 5 units and the A course is worth 2 units, then it will be less than 3.5, and it makes perfect sense. That's why we use that. So let's come up with the table first. We put the grades here. Weight is the number of credit or units, and worth. A is 4 points, F is 0, B is 3, B is 3, D is 1. And if we put those courses, the A was in statistics, which was worth 4 units. F was in physics, 5. And then we had a B and B, 3 units and 2 units, and D in tennis, 1. So you multiply the second column by the third column, and you divide by the weight, the number of units. And that's how your GPA is calculated. Second column times the third column, and you divide by the total number of units or credit that we have, and that's the GPA. Generally speaking, GPAs are reported with 2 decimals. I like to do more in case you answer questions accordingly. We have the following data, and we want to find the value that corresponds to the 75th percentile, 30th percentile, so on and so forth. First and foremost, let's quickly rank it. Okay, I'm assuming that is not a problem for everybody. When we say 75th percentile, really the location, which one of these corresponds to 0.75 as far as the location is concerned? So you look at the numbers, okay, however many you have, 1, 2, 3, 4, 5, 6, 7, 8, you have 8 pieces, and you basically multiply 0.75 by 8, and you say that's the location. Okay, now let me explain this. N is 8. The locator is k over 100 times n. Whenever we say k over 100, I don't want you to be confused with anything. Understand, this number will change in essence to a decimal. 75th percentile, that means 75 over 100. That means basically 0.75. So you are going to multiply 0.75 by 8 and say this is my location. So when we multiply the two, the location gives us the 6th number. Now, what statisticians do, and it really depends on the type of text you're dealing with, when they get to the whole number, okay, then they go in between this and the next number. So the 6th and the 7th number. So 6th and 7th number, and they find the midpoint of the two. Okay, this is number 6. Let me just write number 6, number 7, this is number 8. So that's how they come up with that. Now, with this, using the same strategy, when we say 30th, that means 0.3 times n. So I don't want you to be, this is a formula that is used, L equals k over 100 times n. But where do they come up with that? It's just 0.30 times n. Now 2.4, that means the 2.4th number. Normally, statisticians rounded up the third number, 1, 2, the third one is 15. Again, this is not just strictly the method that everybody uses, but this is one method. The next part, finding the percentile value that corresponds for this number, the methodology is you locate the number. So 44 is here, everybody. You locate the number and you say how many numbers below that. In this case, this is number 6, so there are 5 of it. So 5 below that, that means 5 out of 8. 5 out of 8. And that's the answer, 5/8. And you change it to a percentile. Now, again, number of values less than 44 divided by n. In this case is 5, divided by 8 is 0.625. Now, this one is rounded accordingly, which means P63. If it was 0.621, you would say P62. Okay, everybody? P62. So this is P63. We rounded accordingly. The final part, using the range rule of thumb to estimate the standard deviation. If you recall, we said previously S is R over 4. So because it's ranked data, we can find the range max minus mean and then divided by 4. 72 minus 10, 72 minus 10 divided by 4, And that is the answer, 15.5.
I'm a little confused. Can you go back? Can you redo the letter D?
This one?
Yes, the last
Okay.
part.
Okay, the last part, we went over this concept that according to the range rule of thumb,
Okay.
according to the range rule of thumb, this is how standard deviation is estimated. Range over 4, okay? Range over 4, okay? And the range is 72 max minus 10 minimum. So range divided by 4, 72 minus 10 divided by 4. Sounds good?
Yes, it sounds
All right,
good.
perfect.
Thank you.
My pleasure. All right, we have a bunch of data and we are to construct a frequency distribution table with 4 classes. As far as the number of classes normally you decide, it's been decided that we go with 4 classes. The reason is because we want everybody to come up with the same answer. That's the reason. So the very first thing is to calculate the width. To calculate the width, you really have to come up with the rank data. So I highly recommend you rank it because it's easier to even make up construct a frequency distribution table that way. And so when you rank it, max minus mean is the range. You divide it by the number of classes. So in this case, the largest number is 56. The smallest number is 41. We divide by 4. Why we divide by 4? Because we're going to use 4 classes. 3.75. We have to round up. Otherwise, if you round down, you will not cover all the numbers. If you stick with 3.75, it will be very difficult to do the work. That's why you round it up to a nice and easy number, everybody. Okay? That's the thing. You round it up to a nice and easy number, in this case, 4. Now, the lower limit of the first class, it normally will be given to you. If you're choosing, you can choose any number as follows. Either the smallest number is your lower limit, or a number less than that, which is convenient. What I highly recommend, you guys try the same question at home using 40 instead of 41 and observe, see what happens, and make up a new frequency distribution table. But according to this, if I'm going to go with 41, because I want to show you something, if I'm going to go with 41 as the lower limit of the first class, what happens to the lower limit of the second class? I'm going to add 4. Do you see that, everybody? I'm going to add 4. I'm going to add 4. Those are my lower limits. Now, what about the upper limit here? If you remember,
Do you subtract?
The width is equal to the upper limit minus the lower limit plus 1 unit. Okay, so this is 4. We don't know the upper limit. We know the lower limit to be 41 plus 1, and therefore this becomes 44. I'm showing you how to come up with that. And now you keep on adding the width. You keep on adding the width of 4. Take a look again, just quickly. 41, add up 4. We came up with 44, add up 4. Those are the classes. Now, as far as the frequency is concerned, you have to work it out. So I will give you the answer, but the way you work it out is as follows. You really want to tally, meaning if I were to, for example, 45, I cross it out and I put it here. I put number 1 here. 52, I cross it out and I put number 1 here. At 48, I cross it out and I put it here. 41, I cross it out and I put it here. I'm not going to continue with that, but this is the process. When you're done, you count and you see those frequencies. So that means there are 5 numbers between 41 and 44. There are 8 numbers between 45 and 48 inclusively. That means included, okay? I want to make sure we understand. 41 is in this group, so is 44. 45 is in this group, so is 48. So this is the table, and this is how you come up with that. Let's go to the next part. We are asked to come up with the mean. Remember, we have all pieces of data. So for part B, all you have to do, add them up. For part B, add them up and come up with the answer. So 42, okay, if the first one is 45, and the next one is 52, and all the way to 42, divide by the total of 25, and we know precisely the answer is 1212 over 25, or 48.48. That's the precise answer, everybody. So we know that. We know that. Now, again, the reason it's doable because we have all pieces of data. If we didn't, we couldn't, everybody, but we do. Okay. And so the next part is asking to use the frequency distribution table in Essence to guesstimate this. How do we do that? And I want to go over that for you. If we don't have, if we have the data, we calculate. But if we didn't have, and we just have the frequency distribution table, how do we calculate the average? Remember what's happening here. When we say there are 5 pieces between 41 and 44, what does it mean? If we don't have the data, we don't know. All of them are 41, all of them are 44, or somewhere in between. We have no idea. Same thing goes for the rest of them. So to calculate the mean, statisticians have come up with this idea that we don't know what each value is, but let's assume each value is equal to the midpoint. So 41 plus 44, okay, divided by 2, that gives us the midpoint for the first class, which is 42.5. And then we know the width is 4. Remember, the width was 4. Just add up. And so you calculate, okay, so X bar is the summation of F times X sub M over N. X sub M is the midpoint of each class. We calculate the midpoints, as I said, as follows: 41 plus 44, lower limit, upper limit divided by 2, and then just add the width. You don't have to calculate it again. It's easier to add the width. So now this formula says the way we calculate this, the total sum is 5 times 42.5 plus 8 times 46.5 all the way to the end, and then we divide by, we know the size is 25, not because of here, over here, even if it's given 5, 8, 8, 5, 4, add them up. And you can estimate in this manner. When you do that, you come up with the following answer. Is this the same as this one? Absolutely not. But look at it. It's actually fairly close, isn't it? So with this methodology that we use the midpoints, this seems to actually work out. So yes, they are reasonably close. And that's important for everybody to understand and the process of calculation.